Hello together, my name is Markus Krause, and today we will have a look at the probably most interesting component in a thread network, the border router. A border router connects our thread network with another network, like the internet or a local area network. The thread network using IPv6, and our second network can have IPv6 or IPv4. When we are using IPv4, the border router acts also as a network address translator, so it's using the NAT64. With this structure we can then send from a thread node, which sensing, for example, the temperature, data directly to a server, let's say it's a CoAP server, for example, in the second network, and making the data exchange via the protocol CoAP, or UDP is possible, or MQTT. I will have the network structure for this, like this for this example. I have the thread network, and my local area network has the network address 192.168.8.0/24. So this is the network address, and my border router has the ending 187. And my DSL router, which connects the whole local area network to the internet, has 1 at the end, and my PC has 181. And we will send directly data to the internet for testing, and also sending data to my PC to show that this is working. For our border router, we are needing a little bit hardware. So the main component is the Raspberry Pi, which acting as border router. We have to flash the firmware on it. The Raspberry OS, it's a Debian Lite, Raspberry Lite. For this we are needing also a flash drive. I will flash it with Windows for here, but it's also possible to using Linux. We're needing, of course, that the Raspberry Pi can act as border router, thread network. We're using a radio dongle, so we're using here the nRF52840 USB dongle from Nordic. It costs around $10, so not so much. And as thread node, I'm using the Developerkit, the nRF52840 Developerkit. And yeah, the first step what we have to make is flashing the firmware on the SD card. To install the operation system on the Raspberry Pi, it's quite easy. We're needing the Raspberry Pi imager, and also we are manual downloading its operation system. You can do it directly if you have a stable internet connection. You can make directly with the imager, but for me I like more to having the operation system already on my PC. So we going on the operation system and choosing the right one. We are needing a 32-bit version. The 64-bit version is not working with the border router. It's expect a 32-bit version. Since we should also use an SD card with 32 GB maximum, so it doesn't matter, because we don't have so many memory on the Raspberry Pi. Also for the memory, I think here the RAM is 2 MB, maximum is 8, I think. So 4 it's more than enough, and 2 is also enough. So we are using Raspberry Pi OS Lite. Yeah, so it's without any desktop or something. It's just a terminal. We're going on download and download it and store it somewhere. Yeah, I did this already. And afterwards we are going back and downloading the Raspberry Pi imager. Download for Windows here, and also install it. Then after we are installing it, we start the application. Here you're seeing the overview. We're choosing the operation system. Like I said before, you can either choose it manually, then you would have to go to Raspberry Pi OS Author and choosing here the light version. Then it takes a little bit longer, or you are choosing your own image where you store it before and unpack it and choosing this version. So it's directly transfer. Of course, now we have to plug in our SD cards that it's working. So just plug it in your drive, connect it to the computer. Just make cancel here, choosing the SD card, check that's the right one, and then we have also to go to preferences here, since you don't have to do it if you're having another keyboard and monitor. You can directly access everything, but I will activate here SSH, and I will make a password here, because in earlier times it was common that you're having a Pi user and the password was Raspberry Pi, but in the new version it isn't there anymore, so you have to choose your password by your own, or the first time when it starts, when you're having a keyboard and a terminal. But since I'm using the terminal only without keyboard and another monitor, I have to set password. Then I make save, and then I just make write, and it takes a little bit time until this is finished. When it's finished, we can just remove our our SD card and plug it in our Raspberry Pi. I have already one inside, so I have to make this out first. Put the other card inside. And now we have a plain Raspberry Pi OS, and we have to connect the power supply. Be sure you're using a power supply which has enough power, just starting it. And it starts the Raspberry Pi. You need to know the IP address from your Raspberry Pi when it's starting. It's taking around 2 minutes or 1 minute until it's up. Normally you can look at your DSL router what IP address is when it's in DHCP server to what it gets. If not, you have to plug in the keyboard and a monitor and configure it manually. I got here a fixed IP address, so it's not a problem for me. When it started up, I'm using PuTTY to connect, PuTTY to connect with my Raspberry Pi. I'm seeing here 187 at the end, and just connect with it. Let's see if it's already there. No, it still need time. You see now it's connected. We just have to accept the certificates, accepted since it's encrypted with SSH. The password you choose before, the login, I let the default one, it's Pi, and I'm putting in the password, and you see we have connection to the Raspberry Pi. Before we install the software on our dongle from Nordic, we need also firmware so that it's communicate with the border router. We have to choose which structure we want to implement. There are two different ones, which is called NCP and RCP. NCP is a network coprocessor. There the whole thread components are executed on the dongle itself. And our Raspberry Pi has a connection here using only it's connected via an interface, spinal it's called, or spinal, and it just has the functions from routing the packages and the NAT translation. This is of course quite convenient, since the Thread dongle acts separate from our Raspberry Pi, but the most common way is the second one. It's this structure. Then our dongle only has the basic components, as OpenThread MAC layer and OpenThread drivers implemented, and the rest of the Thread functionality is taken from the Raspberry Pi. This is called RCP, a radio coprocessor. We will implement this version, since Nordic has an example for the NCP, but there you need a Raspberry Pi 3, and I don't have this version, I have only Raspberry Pi 4, and the implementation I will show you is you have just more hardware to implement this. Dongle need also not so much power and so on, so we will implement this version. We're needing a little bit software on the Raspberry Pi, additional software. So be sure your Raspberry Pi has connection to the internet. I have the connection through my DSL router, and it has its own IP address, of course, also in my local area network. And first we have to install Git, since we need a few Git repositories, especially for the radio coprocessor. So we install it via sudo apt get install git. In the next step, we need the software for the Nordic dongle, the firmware. To build this, we need the repository for this nRF52840 chip. This we're making with git clone recursive, and then https github.com OpenThread and then nRF52840-dongle.git. After we having the repository for the stick or for the nRF52840, I mean, we could also use it for the Developerkit, of course, but we are using the dongle. It's cheaper and it looks much more nice if the dongle is only connected to this Raspberry Pi. We go in the directory. The directory is stored in our home directory. It's just OT nRF528XX, and then we have to execute a script, a bootstrap script, that a few dependencies are installed also, like the ARM compiler and a few OpenThread packages. So bootstrap the downloading and installation takes always a little bit time, so be patient, takes a few minutes. After the compiler and so on are installed, we can build the firmware for our dongle. For this we run another script, the build script. We have to set a few parameters, so we are building it for our SoC nRF52840 and we want to have using it via USB. Yeah, we could connect it with the Raspberry Pi or also through other interfaces, but we are using USB. And then dot bootloader USB and the OT. We're taking the thread version 1.0, thread version 1.0. So then enter, then it will be built. When the building process is finished, yeah, we have the whole build files in our directory, in the build directory. We could directly transfer it using nRF util, but since we are using quite new Debian with the Python version 3.9, and the Python version doesn't fit anymore to no, so nRF utils is not up to date, so it's too complicated to make it with nRF utils. So we are just generating a hex file and transfer it manually with the software from Nordic. So we're using the ARM non-RBE object copy and generating a hex file. Hex RCP and making OT and RCP point hex dot hex. So now in our main directory we're seeing that we're having the hex file. Now we're needing the software from Nordic for transferring it, or also we have to transfer first the hex file to our computer. We can use SSH. Yeah, I'm using for this FileZilla, but you can use all other components also. Going to my Raspberry Pi and connect, and you're seeing here I just transfer this file to my folder on this PC, and after this we're going to the website. If not already happened, we are downloading nRF Connect for desktop. Yeah, we're going just to the website from Nordic, download it and install it. Yeah, it's available for Linux, Windows and Mac OS. I installed it for Windows, of course, so I can directly start nRF Connect. For this, of course, I have also to plug in the dongle, so nRF52840 dongle, so I plug it in, and seeing here we're starting, if not already install it before, then we are open the programmer. We have here a programmer overview, but we have to bring this device first, the dongle, in the DFU mode, so device firmware upgrade mode, and for this we have to click the reset button here a while, and then you're seeing it's starting flashing the red light. Yeah. Then we can choose the device here, OpenThread bootloader, and adding our files we just downloaded before. So select it, be sure that it started from the address 1000. Yeah, so that's bootloader itself it's not overwritten, but normally it should be automatically when you're putting the right parameter with the building process. And then just click on write and wait until the flashing is finished. And when it's finished, then just unplug it, plug it in the USB port from our Raspberry Pi. Be sure it's not a USB 3 port, so it's a basic USB 2 port. Plug it in, and our radio coprocessor is already installed on the Raspberry Pi. After we are finished with flashing our radio coprocessor and plug it in the Raspberry Pi, we have to install the border router functionality on the Raspberry Pi. For this we have also to clone a Git repository. Be sure you are in the home directory again, so that you don't make a subfolder in the folder for the radio coprocessor sources. So we are making git clone https github.com OpenThread and OTBR for border router POSIX. Download this repository also. Takes also a little bit. After this we also have to execute the bootstrap script in the folder. Then script bootstrap to install a few dependencies. I mean, the ARM compiler should be already installed, so it should be a little bit faster, but a few packages we are still needing. When this process is finished, we just have to run the setup script. So the border router is running. The most parameter as basic, so there will be a web interface activated, and and also the NAT 6.4 is automatically installed. So you just have to set one parameter. This is where the ETH is the interface, which is our second network connected. So it's a Raspberry Pi, it's a ETH0. So name gleich infra if name gleich ETH0, and then we run the script setup. As this all takes a little bit, the Raspberry Pi is not the fastest computer, but it's more than enough for a border router. After the installation and setup process, we are making a reboot that this installation affects the Raspberry Pi, and that we're having a border router. Now comes the interesting part. After all this long installing, we are setting the parameter for the Raspberry Pi for the border router. So we're going here in the command line interface modus, that we don't have to type so many times sudo otctl. Then we're creating a new data set, init new. After this we are setting the channel, dataset channel. I'm using 11. Okay, data set channel 11. After this I'm setting also the channel mask. FF800. Oops.
So I'm choosing also PAN ID. Does set PAN ID. We have to choose the 16-bit PAN ID, so it should be unique for every thread network in our area. Extended PAN ID. I just copy it, it's going faster. I have always to type, so that's long. So afterwards, copy also the network key. Yes, this is a common network key. Be sure you take a unique one, a secret one when you are choosing your own one. Yeah? But for sniffing and for testing, this one is okay. Then a mesh local prefix for our network and a network name. Afterwards, I'm making this as active data set. Yeah? Starting the network interface and saying thread start. Now the thread network is started. You can look at the parameter data set active. You see here also set parameter. Now we have to add a special IP address or a special network address. This is for the border router functionality. It will give all the devices in the network later address from this network for the routing through the other network. So we have to register this address, and we can show it if we want with netdata show. So you see here's the registered address and the routing. Yeah, now our thread network is started. I can go out here again with Control C and take a look. We have here our web interface. Yeah, you reach it with the IP address from the border router. You can see here status, parameter which we just give, at least the most are here already. And now our border router is already working. For our thread device, we are needing again the nRF5 SDK for Thread and Zigbee. You can download it from the Nordic website. Yeah, be sure you are taking the nRF5 SDK and not the nRF Connect. So it's a little bit more complicated to install. So this one you just download, and like in the tutorial before, we program already with it. We just go in the folder, in the example. We need a command line interface example, just using the basic one from Thread, CLI, FTD, UART, and we using the Developerkit, so we are using PCA 100.56 and going here in the blank SAS for the project file and starting Sega Embedded Studio. Yeah, we just compile it. It is already compiled. I'll plug it in there, and then we transfer this image to our device. Now we connect to our Developerkit. It's at COM3. Of course, we could set here the parameter from the network via dataset, but this is not so convenient. So we are using the border router as commissioner. So we're going first in the command line mode again. Didn't work. So after this, we are making commissioner start. Now the commissioner is active. We are adding a joiner add. You can limit it via IP address or whatever. We allow now every device, and setting J01 NMA
as passphrase. Be sure there are numbers in it. If not, you will not allow it. You can also look which joiner are allowed. There is a table, joiner table, and we have only a limited time. This will go down the time how long to join. You can extend it if you set the seconds here at the end. You can make it longer, but it's only limited for a specific time. On the Developerkit, we're making a factory reset first. That the device is clean. If the network is already started, you can just make thread stop, so it's necessary that the network is not started. Then you be sure if config is up, and then you just join the network. You try to join the parameters. No, did copy it. Joiner start J. So you see here is a joiner request coming. It's take a little bit while until he gets the data set. Join is successful, data set active. So we see here we got the channel, the PAN ID and the master key from this, and now we have to start the thread network. It's not automatically starting, yeah. So just start, and then you get even the rest of the data, yeah. So you see here, oops, data set active. So now the list is more complete, yeah. And after this, actually, it's everything already working. You can directly ping through the internet via the DSL router. I have here IPv4 DSL router only, so I need an IPv4 address. And for this, I'm using 8888 as an example from the Google DNS. But we have to set a prefix before that the border router is recognized that this is an IPv4 address. The well-known prefix is 64:FF9B : is a well-known prefix which is used normal for this. Yeah. So we can then ping with the prefix and then add 8888. Normally we have to translate it through a IPv6 address, but this will be done automatically. So when we're making now a ping, we see we are reaching the Google DNS. And we can also protocol this, but for this we install install TCP dump. Oops. TCP dump. I have to put sudo on it before, of course. So and since we're having here now more interfaces, we have the ETH0 where our LAN is connected. We're having a NAT64 for the translation process, and the VPAN0 where our radio co-processor dongle is connected. Yeah, so we make a TCP dump with the interface NAT64. Make it with numbers only. I have of course also to make sudo. So when I make now the ping again, you see that this ping here is translated then directly to 888 and 8888, and then we're getting the answers back. Yes, it's this is IPv6 address actually is a complete one. Yeah, we have here another problem when I want to ping here my computer in the same network 131 in the local area network. I'm making a ping.
the ping doesn't go through, so there I don't get an answer even when the ping from Google is still working. Yes, this is because with this prefix here, the border router isn't allowed to route in a local network, so no private addresses are routed. There is a trick for this. You have to use another prefix, GUA, Global Unicast Address prefix, and you have to configure it in the configuration of Tiger. Tiger is a NAT translator, NAT64 translator. So we open the configuration file, and you see here is somewhere the prefix. Here you see the prefix. Just uncommand this and using this one. And when we're using this one, I have it already prepared here. We are saving it, saving X. And afterwards we have to restart Tiger. Sudo system ctl restart Tiger. Tiger. So now we can of course not reach Google anymore with this IP address. I will not go through because we have another prefix. Didn't help anything. So when we're using now this prefix, we get still an answer. And when we're using this error, when we're using now this address, we will get also now an answer. And now we can also test this with a CoAP-server since our computer is reachable. At the end we will make a short CoAP example. So I'm using the example from my tutorial before. It's just a CoAP client, the Threaddevice, and the resource is stored data. I'm sending there the temperature data with my Threaddevice. I just exchange the IP address to the IP address from my PC, and I will start a CoAP server. It's a Python server. You can here see the short script. Yeah, we just find here resource, the IP address, and the CoAP port, and then I'm starting it with Python server .py, and with the button I'm sending the data. You're seeing here that the temperature data is directly coming. Yeah. It's really beautiful to be able to send directly data to a server without any translation. We can also see the incoming data here with Wireshark. We can sniffer it. I have the sniffer stick connected to my PC, and you're seeing here the IP address and the CoAP-message also. Yeah. As this was a little bit longer this time, this video, since the installation process takes really a little bit time. Yeah, it's really beautiful. We have a lot of use cases here which are possible now, since we can directly send data to any server in the internet or in our local area network without translating something, without using a gateway and so on. It's really nice. I have only a few questions left which I didn't find an answer. Actually only 2 questions. There you know that we can ping from the Threaddevice our PC. It doesn't work, it goes through, and even when I send it from the Raspberry Pi directly, this ping, yeah, it also goes through. Yeah? You're seeing here the answer, it's working everything well. But this doesn't work when I use this OpenThread for this. So this is also an OpenThread device, not only connected to the internet. When I'm using OT, ZTL, the ping doesn't go through. Yeah? And I didn't really find an answer. It's lost. And when we sniff here, seeing when I make the ping, actually I get the echo here.
The echo reply is coming to the NAT64, but it doesn't come to the VPAN 0, and I didn't understand this. The IP tables are okay and so on. We should getting an answer. If someone knows an answer, please inform me. It would be nice to know. It's not really a problem because we will not use the Raspberry Pi, probably for something different in the thread network, but would be still nice to know. Another thing is that we are setting these IP addresses. You remember the IP address which are especially for the routing process to the border router, the FD11 address here. We have this also in the Raspberry Pi. Remember that we are setting it with prefix and net data register. The problem is the data set, when the Raspberry Pi is restarted, it's also saved, but the net data is not stored somewhere, and we have to set it again. I mean, it can be done with the script after restart, but it's not so convenient. It would be nicer if it's permanently stored somewhere. But yeah, wasn't. So if someone knows their solution, please inform me also. I hope the information in this video was useful for you and you could build up your own border router now. And if you have something, write a comment and inform me. A like would be nice, or abonnement of course also. And see you the next time.